Right, a bigger wheel. So I've moved the gap down lower because the wheel is lower. I'm going to add some weight to it as well. And find where it is. Too much power. I could loosen it again, so it's got more of a hill. I could put the propeller on backwards and it'd be less power. Didn't think of that. Still too much power. Right, propeller on backwards. Crazy, we're trying to reduce the power. on backwards. Backwards propeller, and maybe a bit more weight. That's a lot less power, isn't it? Alright, put the other propeller back on again. The right way round. And put all the weight on. Well, that is what it's supposed to do. So that was holding that up quite a bit higher. Probably means it'll be going too fast at the other end now. Alright. Here we go again. Oh. Right, well, I would say we finally got it working there. So it was really loose line. It might be different on a longer distance, but certainly over this distance we had to have it very loose. It does concern me that it's quite noisy. Don't want to upset my neighbours. And I did have to add some nose weight. Quite a bit of nose weight. But I think I'm gonna stop there. That appears to work. If you download the files and put it together yourself, it really depends what size motor you want to use there. You may have to change that bit there and make the hole bigger. So I'll arrange it so that's the last bit that you edit if you decide to edit the file, so you can change the size of it. But yeah, bigger pulley seemed to make it run smoother. It's a rather nice pulley actually, that one, isn't it? So bigger pulley, lots of weight to make sure it holds the zip wire down so that we do get this steep slope at the end to slow it up. And when it slows up, that gives it a chance to actually spin round. Now, on one of these versions I actually had this quite a bit far forwards to make the nose heavier, so it did tend to tip round like that anyway. So I'm not sure whether I ought to have that longer nose, more weight at the front. That helps it to turn. Also, I wasn't watching which way it was turning. I've an idea that's the way it's turning, which is totally wrong. It should be pushing itself round. I'm gonna have to run it one more time just to see which way it's turning. I think we lost a bit of propeller then. Got a bit of something stuck to the propeller. Anyway, that was turning the right way. So, yeah. It looks untidy now with all that weight on the front. Could be developed more, I think, is the answer. Not perfect, but it does work. just a summary of where we're up to with this reversing cable car. I was using that size pulley, but I've changed it to a nice big one. That seems to give it freer movement. I did have pulleys on either end, which I've replaced now with these forks. And I've got holes drilled in those forks, so we can put a stopper across to stop the line coming off again. Originally I had that at the top, but that was giving too much, it was rocking too much that way. So then I drilled that hole to reduce it down to that, but then with the big wheel we need the line to come across at a lower level. So I moved that down to there, or there, I can't remember which one. What I'll do when I do the files, I'll put a whole load of holes through there so you can choose your position, and I'll put both sizes of pulley on the file as well, so you can choose which one you want to print. This bit here, I've done several versions of this. That was the first one, which was much smaller. That was another version. Oh, and that was the one I did that was much longer at the front. So it automatically had more weight at the front compared to the pivot point, and that seemed to help it turn a bit. But I was then worried that it was turning under gravity and it might stick in that position, whereas the idea is it's supposed to push itself round. So that's why I shortened it again. So yeah, all sorts of variations there, but this worked. I mean, that's what we came down to. This one worked. Had to have quite a slack line for it to work, because the idea is it slows down when it gets to the steep bit, which gives it a chance to spin round and go the other way. Oh, this is just a drinking straw. I was trying to do it with one hand, but it's a drinking straw with a little bit of a split in it, so it folds up on itself, pushed inside another one, so we can change the length to adjust the overall length. And that's just a thin bit of foam on there for the fin or rudder, and that helps to straighten it up when it's going along. Check the video description, there'll be a link to David Vernon Williamson's own design, and he does it entirely with paper clips and drinking straws. So you don't need a 3D printer to do it, and his looks more elegant. I like his, but I wanted to see if I could do it 3D printing. These are just odd scraps of plastic that I've been using to go across there. Oh, and the wire, that's garden wire, galvanised garden wire, which you have to straighten before you use it, so if you've got some straight stuff it would be better. And that's an electrical connector that I'm just using to clamp it in place, and then some plastic beads. Oh, obviously a small LiPo battery, an on-off switch, and then the motor. Yeah, I've had to sacrifice quite a few little helicopters and that sort of thing. All sorts of different sized motors I've used, and they seem to keep dying on me. Well, one thing that happened when I had the propeller facing forwards, when it hit the wall, it actually pushed the shaft straight through and pushed the back cover off. And that's a real pain trying to get that back cover on, because you crush up the brushes and that sort of thing. So that's why I turned it around so it's a pusher instead of a puller, to protect the motor. I think that's long enough summary. Thanks for watching. You'll find more information down in the video description. You might like to watch that video up there, and you might like to subscribe over there.